Hello, welcome to another video of Mathematics 10. And today we're going to talk about solving systems of linear equations using the substitution method. So before we get started, there are some important things we need to know about solving linear equations. First thing, you should know how to solve a linear equation. 3x minus 5 equals 10. Hopefully you know how to solve that. And the second thing you need to know how to do is evaluate, find the value of the expression 2y plus 4 if y equals -3. By the way, the answer for the first question is going to be 5. And the answer for the second question is going to be 2 times -3, -6 plus 4, so -2. Using those prior knowledges, we're going to be able to solve a system of two linear equations using the substitution method. So important thing is that today we're going to look at two equations at the same time, and we're going to solve two variables at the same time as well. Let's try the example question. Solve the system y equals -2 and -2x plus y equals -8. Well, let's write them side by side on top of each other first. So this is relatively an easy question because one of the variables is already given for us. Y is -2. The only thing we need to do is we need to substitute the value of y as -2 into the second equation. So if I mark that as equation 1 and equation 2, I'm going to substitute the equation 1 into this equation number 2. So let's see what happens if you do that. -2x stays the same, but instead of writing y, I'm going to replace y with -2. Just be careful. The first time you do the substitution, make sure you put the bracket just to protect it, especially when you're dealing with negative numbers. Anyways, if I proceed, -2x plus -2y, it's going to be -2x minus 2 equals -8. And now observe what we have. We simply have a single equation with a single variable. Now let's solve that equation. I can add 2 on both sides. -8 plus 2 is -6. And then I can divide both sides by -2. So I get x equals -6 divided by -2 is +3. And voila, I've solved x as 3. I also know the y is -2. So I can write this answer as x equals 3 and y equals -2. That is my final answer. Or if you want to write it in a different way, we can write it instead as 3 comma -2. As if the x and y, the values are the coordinates of a point. So the x coordinate is 3 and the y coordinate is -2. Let me write down the annotation of each step that I followed. The first thing I did was label each equation and substitute 1 into 2. Let's also make sure that use brackets. And then the steps after that is pretty straightforward. After we substitute it, we make sure that we have a single variable with a single equation. So solve the linear equation. And that is the summary of the following steps. And then I can just write down at the end, write both answers. Or in a coordinate form. Let's move on to the second example question. This time we're solving the system y equals x plus 1 and 2x plus y equals 7. Let's do the same thing. Let's write down the equation as we see. The first step I'm going to do is I'm going to label each equation. Well, this time again, I'm going to use the substitution method to go from 1 into a 2. Right? I can do that because y, the first equation, the y is isolated nicely. It's already done for us. So we can just substitute the y in the second equation with the x plus 1. Why can we do that? Because y is x plus 1. They're identical to each other. So there's no problem for us to substitute x plus 1 into the second equation. So let's do that. I'll write 2x plus, and instead of writing y, I'll put bracket x plus 1. Always remember to use brackets to avoid any mistakes. This time, there was no need for a bracket, but still, it's good to protect. So that's 2x plus x plus 1 equals 7. And now, once again, you notice that this is an equation with a single variable. We need to do collect like terms first. Let's collect like terms. That's 3x. And then also let's do minus 1 on both sides. That's going to be 3x is equal to 7 minus 1, which is 6. And then solve the equation by dividing by 3 on both sides. That's x equals 2. So we got x equals 2. And we're not done yet this time because we actually don't know the value of y. Well, no problem, because we have the first equation that y is x plus 1. So if x is 2, what does that mean? I can write it as y equals x plus 1. So that's going to be y equals 2 plus 1. Once again, I'm substituting the value of x as 2 into one of the equations. Y equals 2 plus 1, y equals 3. And therefore, this concludes the question. I found that x equals 2 and y equals 3. Or we can write this as a coordinate, 2, 3. Either or. Let me annotate it one more time. Well, I will only annotate what I need to do. The same thing, we label the equations 1 and 2, and then we substitute the first equation into the second equation using the brackets. And then we solve the linear equation and we get x equals 2. And afterwards, after I found one of the variable, I find another variable y by substituting x equals 2 into equation 1. I substituted x equals 2 into the equation number 1, y equals x plus 1. Therefore, I found the y value, and therefore my answers are x equals 2, y equals 3, or 2, 3. So in today's class, there is some that we need to know about. First one is the systems of equations. The systems of equations refers to a set of 2 or more equations. Right now, we're only looking at 2 equations, and we have 2 variables. In future, in long future, if you wish to take some calculus and matrix and linear algebra, maybe you'll have 3 equations, 3 variables, or 4 equations, 4 variables. That's for the future. In high school level, we're good with 2 and 2. A solution to a system. Usually a solution refers to x equals something, y equals something. But this time, when we're solving a systems of equations, we're going to have a collection of the points. X equals this and y equals that. Or we can write it as the point, as a coordinate system that makes all equations true. And the last vocabulary, the substitution method. The substitution method is a way to solve a systems of of equations by isolating one variable, either x or y, in one equation. So we solve that single equation, and then you're plugging that expression into the other equation. That's what we did for the example 2. We solved for x first, and then we plug it in to the first equation to get the y value as well. So we find one equation, and then we find the other. We solve one equation to get one variable, and then we solve the other equation to get the second variable. So that concludes today's video. I'll see you in the next one.